Hi everyone, this is part 2 of the Mathematics Paper 1 trial exam, question 1. So as I had promised, after finishing 1.1.4 in part 1, I said I was going to do 1.2. So this is question 1.2. I'm still doing question 1. If you want to see the paper, you can check the description below. I left a PDF there. You can also check part 1 if you haven't watched it. At the end of the session, it will pop up on the screen, and also part 3 as well. So let's start with this one, with 1.2. We are given this equation here and this equation, and 1.2.1 is asking us to show that the equation, this equation above is equal to y is equal to negative x minus 2. So let's go to the question. In a question like this, I try to find a way whereby I can get rid of the bases so that I can have y in terms of x as shown here. So what you need to do here is to find a way to write the bases such that they are all the same so that you can equate the exponents. So let's go. We can represent 4 as 2 to the power 2, and of course we have x plus 2 there. And 8 can be represented as 2 to the power 3, and of course we have to account for y plus 1 as well, and that's going to be equal to 2 to the power of 1 minus x. So now all bases are the same. That's a good thing, but then let's try to simplify to make things easy for us, to make things easier. So we're going to have 2 to the power here, 2 to the power 2 multiplied by x is going to be 2x, 2 multiplied by 2 is going to be equal to 4, 3 multiplied by y is 3y, 3 multiplied by 1 is 3, and then we have that expression there. Now what we can do here, remember in the is one of the laws of exponents is I don't know its name, but if you have a to the power, say x, multiplied by a to the power of y, that's the same as a to the power of x plus y. So if bases are the same, you add the exponents. So that's the same thing here. 2 is common. We're going to add the exponents. As a result, we're going to have 2x plus 4 plus 3y plus 3. And that's going to be equal to 2 to the power of 1 minus x. Now, because of that, we have the bases. Bases are equal. So if you have, let's say, a to the power m equal to a to the power v, let's say equal to a, this is a to the power v. Therefore, m is going to be equal to v. So if bases are the same, we equate the exponents. The same thing applies here. Because we have 2 at the base and 2 at the base, we're going to equate this expression on top with that expression on top there. So we're going to have 2x plus 4 plus 3y plus 3 is equal to 1 minus x. Now we're going to have y on the left and everything that has x on the right, including the constants. So let me write 1 minus x as it is. 2x comes to this side, becomes negative 2x. 4 comes to this side, becomes negative 4. Almost wrote a 7 there. That's negative 4. And 3 comes to this side, it becomes negative. So 1. Negative x minus x is negative 3x. Negative 4 minus 3 is negative 7. 1 minus 7 is negative 6. So we're gonna have, we will end up with something like this. Y is equal to 3y is going to be equal to negative 3x minus 6. But then we have to divide by 3y here, by 3, because we want to get rid of that coefficient. So we divide by 3 on both sides. As a result, negative 3x divided by 3 is going to be negative x. Negative 6 divided by 3 is going to be negative 2. So that's how you do this question. Now we're going to go to 1.2.2. On 1.2.2 they say hence solve for x and y simultaneously. Okay, so for us to solve this equation simultaneously, and provided that we are also told, let me show this, we are also told, they said hence solve for x and y simultaneously. Hence implies that you should use the result you got from the previous question. So in the previous question we found that this equation here can be written such that y is equal to negative x minus 2. So we already have something simpler. Why don't we just substitute this y is equal to negative x minus 2 into equation 2, the more complex equation at the bottom. So how we would do that would be to say, let's say therefore, not therefore because it's not like there is a result here. So we're gonna write x squared as it is plus y squared. But then instead of writing y squared, we're gonna write negative x minus 2. We are substituting the expression we got, the equation we got from 1 into 2, into equation 2. So x multiplied by y is negative x minus 2, negative x minus 2, and then we're going to have 7 here, there. And then let's expand everything. That's going to be minus, there's a square here, forgot to write it. So plus, this is negative x minus 2, negative x minus 2. The square becomes that. Remember, if you have a squared, it's the same as a multiplied by a. That's why I have this here. And then let me multiply out this already. I have a negative here because a positive and a negative when multiplied give a negative. So, and x multiplied by x gives x squared. X multiplied by negative 2x gives negative 2x. That's going to be equal to 7, but then we can take 7 to this side and change its sign and equate the whole thing to 0. So 7 comes this side and everything is equal to 0. Already x squared and x squared cancel each other out. And then we multiply this one out. Negative x multiplied by negative x is positive x squared. Negative x times by negative 2 there is positive 2x. Negative x times by negative 2 there is positive 2x. And negative 2 times negative 2 is positive 4. And then we're going to put this as it is. Now we're going to get something that resembles a quadratic expression, which should in principle make things easy. 2x and 2x cancel. We have only one 2x. 4 minus 7 is negative 3. That's equal to 0. Now when we have this, we can then find our factors. So what are we going to put here? The trick I use is this one. What two values do you multiply to get x squared? You multiply x and x. What two numbers do you multiply to get 3? It's 3 and 1. Now when you cross multiply this number and you cross multiply this number, you will get, for example, x times 1 is going to be x. X times 3 is going to be 3x. When you add them together, they should give you the middle term. So what can you do in their signs to give you the middle term? you would make x negative. Negative x plus 3x should give you 2x. And it doesn't it. But then, where does negative x come from? Negative x comes from x multiplied by 1. But where does the negative come from? We have to compensate for it, so we put a negative there. So that's negative 1. And since 3x is positive, we just put a positive there as well. And we have the brackets. So the first bracket will be x plus 3. The second bracket will be x minus 1, x minus 1. Therefore, we're going to have x is equal to negative 3, or x is equal to 1. I'm just going to make an example using one of these expressions here. The reason x is equal to 1 is because x minus 1 is equated to 0. That means we will have x is equal to 1 when we take negative to this side. So that's why we have this value here. Yeah, I think this is enough for today. Please comment, like, and subscribe. And comment if you have something that you don't, you're not particularly clear with. And the next video, part 3, will be available on the screen. It will pop up now. If you want part 2 and part 1, you can press on the left. Thank you.